Welcome back. We're working on the Algebra 2 Unit 2 test review. We are currently on problems 17 and 18, the piecewise functions. We are going to start with problem number 17, which is evaluating some numbers in the piecewise function. We like to go with the number line system here, or at least we find it handy for people who like visuals. Set up a number line. Since we have two equations, we know we're splitting this in half. The number that we're going to split it at will be 3. Since the top equation has the equal to, the less than equal to, let's put a less than there so we know that when we hit 3 that we're actually going to use the equation on the left of 3. So up to the left, we are going to be using the equation 2x plus 1. On the right, looks like we're using the equation negative 4x. So now we just fill in. For A, we got f of 7. So 7 would be to the right of 3 on the number line. So we're going to use the negative 4x equation. So put the 7 in for the x there. Do our math. Negative 4 times 7 will give us negative 28. So we can either write it out as f of 7 equals negative 28. Or if you'd rather, we can do the point that we end up plotting, which would be at 7n, negative 28. For B, we're doing f of 3. Notice 3 is the point where we're switching. That's why we did that less than. So less than, we're going to the left. So we're going to use the 2x plus 1 equation for 3. So put the 3 in for the x there. 2 times the 3 should give us 6. Add the 6 and the 1, we got 7. So we can either write it out as f of 3 equals 7. Or once again, we can list it as a point at 3, 7. Part C, we're dealing with negative 5, which should be to the left of negative 3 someplace. Doesn't really matter where, just to the left. So we're using the 2x plus 1, so put the negative 5 in for the x there. 2 times the negative 5 will give us negative 10. And when we add the 1, we get negative 9. So the f of negative 5 would equal negative 9, or we can write it as the point, negative 5, negative 9. For the graphing for 18, I'm going to run through 2 different methods to do this. First method I'm going to use is the one I highly recommend, which is the table method. So we're going to make up a couple tables. One table uses the 3x minus 4, the other one uses the negative x plus 1. As far as the numbers, the x's we're going to put in, that will depend on this if part. So for the first one, the 3x minus 4, we want to use 2, and we want to use numbers to the left of 2, less than or equal to 2. So to the left of 2 on the number line, we'd have numbers like 1 and 0. And we may want to note at this point, since this equation has the equal to, because it's less than or equal to, this one's going to get the closed circle. For the bottom equation, we're doing the ones where x is greater than 2, so we start at 2. Numbers to the right of 2 on number line would be things like 3 and 4. Note you can use whatever numbers you want as long as they're to the right. This one did not have the equal to part. So we know as far as the graph goes, this one's going to get the open circle. All right, so let's do the math on this. Put the 2 in for the x. So we should be getting a point at 2, 2, hopefully. Put the 1 in for the x. 3 times 1. 3, subtract the 4, should be getting negative 1, so we'll point at 1 and negative 1. And 0. Plugging that in, anything times 0 is 0. Alright, so let's graph these. As a reminder, we got the closed circle with the 2. So we're going to have a closed circle and a point at 2, 2. We're going to have a point at 1 and -1, and a point at 0 and -4. So for this one, you know we're starting at the 2, 2, and we're going to the left. So we're going to fill our line in this way. Just a smidge so we can see this a little better. Working the bottom table. Alright, putting the 2 in for the x, we have -2 plus 1, so that should give us -1. Point at 2 and -1. Putting the 3 in, -3 plus 1 should be -2. Plugging the 4 in, looks like we're getting -3 for that one. So point at 4 and -3. As a reminder, this one had the open circle. So at 2, -1, we want an open circle. And then we're going to plot the 3, -2, and 4, -3. In this case, we're starting at the open circle and we're going to the right. Note there should be no overlap in the graph. The closest we come is if we look at it, when x is 2, we have a closed circle over the open circle. Only one of them technically has a y value, so we still got a function in good shape. All right. Some people find the second method a little bit easier. This is what I call the graph and erase method. Doesn't work, however, if you got a pen. Here, we're just going to graph the lines normally and then go back and erase what we don't want. So, try and stay consistent with the colors here. So, for the 3x minus 4, it's in slope-intercept form, so we're going to start at -4 on the y-axis and use our slope of 3. So we're going to go up 3 and over 1. Plot some points, so we'll go down 3 into the left one to get another point or 2 there. Sketch our line. Going to the second equation, we look at as y equals -x plus 1, so our intercept is at 1, or the y-intercept I should say. Slope is -1, so we're going down 1 to the right 1, or up 1, left 1. At this point, this is where we take advantage of the if part. At 2, if you remember x equals 2 would be a vertical line. It means we're going to split the graph right along the vertical line. X equals 2. The top line, the blue line, we're only need to keep the left half, so only the part to the left. Of the red dotted line. So we're going to erase everything to the right of the red dotted line. Since this one has the equal to part with it, we want to make sure this is a big closed circle there. For the green line, we're going to the right, so we only want the right half. So everything to the left of the red dotted line needs to get erased. This is where we got to be really careful. Readjust this a little bit. Alright, that's going to be okay because we needed to make this point at the 2, -1 and open circle. Hopefully this helps. Good luck on the test.